Here is another chain rule for multivariable function. So this time z is in terms of x and y, two independent variables. So we have z equals to sum x and y. Two independent variables, x and y, the value of z depends on x and y, so x and y are independent, z is a dependent variable. But for z and y, each independent variables is in terms of two variables, let's say s and t, so x is in terms of s and t, y is in terms of s and t, so x and y, they have two variables within each x and y, so that will be s and t. So when you do the partial derivative, we will have to do one partial derivative with respect to s and one partial derivative with respect to t. So we have partial derivative of function z, so this one is like z, so partial derivative of function z with respect to s. So this is just like the chain rule that we discussed previously. So we have to do one for x and then one for y. So the one for x, we have the partial derivative of z with respect to x, and then x is in terms of s and t, right? So we will just do one for s, and then we do another chain rule for t. So this will be just for the first variable s. Partial derivative of z with respect to x, and then we take care of the x with respect to s. Okay, x is in terms of s, right? So first we take care of the partial derivative of z with respect to x, but x is in terms of s, so we will immediately take care of that with respect to s. So this whole part is for s, and then one for y, because z has x and y, right? So for y, we do the partial derivative of z with respect to y, and then immediately we take care of the y with respect to s. So we have s in x and s in y. And then for the independent variable s, we have one part for x, one part for y, we add them together. So now the s is done. And then moving on to variable t, so we have the partial derivative of z with respect to t, and then z is in terms of x, so we do one for x, one for y, and then for x we take the partial derivative with respect to x, and then immediately we take care of the x with respect to t. So that will be the variable t in x and one variable t in y, right? So and then we add the partial derivative of z with respect to y, and then immediately we take care of the y with respect to t. So let's do an example. So this one I have z equals to inverse tangent, you can call this arctangent of x squared plus y squared. X is in terms of two variables, s and t, and then y is in s and t as well, so t times e to the s, and then x is s times lmt. All right, so let's take care of the variable s first. So we have the partial derivative of z with respect to s. So first we take care of the x first. Okay, so what is the derivative of tangent? The derivative of tangent is 1 over 1 plus the square of everything inside the parenthesis, which is x squared plus y squared. And then that is supposed to be a 1 on top, right? 1 over the whole thing. And then you will have to do a chain rule. So this chain rule is for this x squared plus y squared. So that is for x. So the derivative of x squared plus y squared with respect to x is 2x, right? You can do a 2x plus 0. So how about this? For save some space, I am going to put the 2x up here, and then plus the derivative of y squared is 0. It's optional, but I prefer to write the 0 out. And then when you clean that up, you can just take away the 0. And then what else? And then the derivative of x with respect to s. The derivative of x with respect to s, so this is the only variable. In this case, lnt is a constant, so let's treat that as a tan. So tan s. And then the derivative of that is the s becomes 1 because s times a constant, this is a linear term. So that will be multiplied. I prefer to write a dot. So now I know that I am working on this. So that will be a lnt. Okay, and then we do a big plus. This big plus is right there. What's next? And then we have okay, let me clean that up because okay, so plus the partial derivative of z with respect to y. So once again, we will just take the whole thing in the denominator. So 1 plus everything square, and then 1 divided by that, right? Okay, so put the x squared plus y squared in here. So this time we are taking the derivative of x squared plus y squared, but this time is with respect to y. So with respect to y, then x is a constant. The derivative of constant is 0. The derivative of y squared is 2y. Okay, so that part is done, and then we do a dot. So for multiply the derivative of y with respect to s. So the derivative of y with respect to s, e to the anything is e to the anything, right? So that is just t times e to the anything. Okay, so what if that is a phi s, then and then by chain rule you multiply by phi if that is a phi s, all right? Okay, let's draw a line to clean this up. So the partial derivative of z with respect to s, so that will be, do they share anything in common? Yup, they share 2, right? I can do a 2, and then 1 plus the square. All right, and then I have x times ln t. Hey, where is my ln? Did I accidentally erase that? I think all of you wrote that on your paper, but I accidentally erased that. Remember, I clicked the back button, right? So ln t. Totally forgot that. So we have x times ln t, and then plus, and then that will be a y, and then t e to the s power. Okay, so that is for the variable s. Okay, so now it's time to take care of the t. Okay, so next line, so that will be the partial derivative of z with respect to t. So first of all, we take that with respect to x, so that will be once again 1 plus. We are taking care of the derivative of inverse tangent. The top is supposed to be a 1, and then when you take the derivative with respect to when you take the derivative of everything inside, so x squared plus y squared with respect to x, so that will be a 2x plus 0. Okay, 2x plus 0, and then what else? And then we are doing this, the derivative of x with respect to t. So this time that will be the ln t. The ln t derivative is 1 over t, right? So we have the s in front, so that is s over t. And then we do a big plus. So this time is with respect to y. Okay, so let's take care of the inverse tangent. 1 plus x squared plus y squared, and then square. And then what is that with respect to? With respect to y, right? Okay, then y squared is a variable. So x squared 0. Derivative of y squared is 2y, and then we multiply derivative of y with respect to t. So the derivative of y with respect to t. So t is the only variable. The derivative of a linear term, t, is 1. So that means we only have a e to the s power survive, and then we clean that up. The partial derivative of z with respect to t, can we factor out anything? Yup, just like the previous one, the 2, and then the 1 plus the square. What else? Okay, I guess that's it. So the first term, xs over t, and then plus the next term is 2y. Oh, the 2 is factored out, and that will be a y e to the s power. Right, so that is the derivative of z with respect to t. Okay, how about this? Let's do one more function. So let me pick a different color. Let's do one more function. How about this? Number 2. What should I take? Z equals to e to the r, and then cosine of theta. And then r is in terms of s and t. Okay, just do s times t, and then theta is in terms of s and t. So how about s squared plus t squared? How's that? And then, first of all, we have to take the partial derivative with respect to s, right? Okay. Can you do this? So that will be, first of all, we will take care the derivative 1 for r, 1 for theta. Okay, how about this? Let's do this up. So this will be like for r, and then we do a plus, and then 1 for theta. Okay, that will be helpful. And then first of all, with respect to r, and then immediately multiply, take care of the r with respect to, how about variable s? So that will be like s in r. Okay, and then for theta, so that will be the partial derivative of z with respect to theta. And then we multiply the partial derivative of theta with respect to, so this time is still an s, and then we do another line for t. So that will be with respect to s. So that will be a s in theta. Okay, let's do the work. So that will be a partial z, and then with respect to s. So the whole thing with respect to r, so that means r is the only variable. So this will be e to the anything is e to the anything. Cosine theta is just a constant. And then we do the dot. Dot means we are doing dr ds. With respect to s is the only variable. And then the derivative of a constant of a linear term is 1. So this is a t. And then plus, now with respect to theta, so cosine theta is a variable. So the derivative of cosine is negative sign. So we will have e to the r and then negative sign of theta. And then a dot, this dot right here. And then derivative of theta with respect to s. Okay, so we will bring the 1/2 down, right? Because the square root is 1/2 power. This is negative 1/2. 1/2 minus 1 is that. S squared plus t squared. Who is the variable? S. So the derivative of s squared is 2s. Okay, clean that up. This one, I guess we can factor out the e to the r. And then I have a t cosine, a minus. The 2s and the 2 is cancelled, and then the negative 1/2 that produce a square root in the denominator, ts squared plus t squared. I definitely forgot the square right there, so t squared, and then what else? What is on top? The 2's are cancelled. I have a sine on top, so I have a sine of theta. What else? E is factored out, and then I have a variable s. This one right here, the variable s. Okay, so s, and then I think that's it. So that is the dz ds. Okay, and then we have to do one more for r. So that will be the partial derivative of z with respect to r. Oh, it's not with respect to r, right? We have st, so 1 for s and then 1 for t. So 1 for t, and then there must be a plus, and then I have to do this. So that will be for r, 1 for theta, because z is in terms of r and theta. So obviously that will be a dz dr, right? Or partial derivative of z with respect to r, and then this will be the partial z with respect to theta. And then within r, last one we took care of the s, so this time we will take care of the t, so that will be the t in r. This is also t in r, so that will be a partial r with respect to t, and then partial r with respect to t. Partial theta. I always go like this, right? Partial z with respect to theta, and then immediately you take care of the theta, just like a cross multiply. So partial z with respect to r, and then just like cross multiply, you immediately take care of the r. All right. T in r, that one is t in r. No, that one is t in theta, huh? T in r and then t in theta. Okay. And then partial z with respect to t, so that is equals to, with respect to r, so e to the r is still e to the r. Okay, and then go to function r with respect to t, function r with respect to t, so t is a linear term. Then that will be just a s. But I forgot to write the cosine. So that will be a cosine of theta. In this case, cosine of theta is a constant, so that stays with the e to the r. And then the derivative of st with respect to t is just the s left. It's s times 1 plus. And then partial z with respect to theta, so cosine of theta is negative sign, so e to the r, negative sign of theta. And then partial theta with respect to t, which is right here. So just like the last one, we have to bring the 1/2 down, and then negative 1/2 power, s squared plus t squared, and then we multiply the derivative of what? With respect to t, right? So this time will be a 2t. It is supposed to be a 0 plus 2t because the derivative of s squared is 0. So this one is from the chain rule. The chain rule of what? The chain rule of this. So that one is for the chain rule of that. So you can make a note. So when you go back to review your notes, like maybe 5 weeks from now, you are not going to get lost in that part. Okay, the next line. I will just clean up. So clean up, then that will be a s e to the r cosine of theta, and then plus, actually it becomes a minus because there is a minus in front of theta, right? I mean sine. So this will be the negative square root s squared plus t squared, and then the 2's are cancelled. So this will be a e to the r sine of theta, and then what else? Ooh, there is a t. Okay, can we rewrite that? So partial z with respect to t, I can factor out e to the r. That's what they share in common. So this will be a variable s times cosine of theta, and then minus t sine of theta divided by the square root of s squared plus t squared. There we go. Yep, that will be the partial derivative. So this will be the partial z with respect to t. The last one is with respect to s. Because the idea is we have z in terms of two independent variables, r and theta. But within each independent variable r, there are two more variables. So we have to take the derivative of that and then go inside to take care of the r, and then go inside to take care of the theta. So that is the chain rule for this case. All right, so that is the end of this video. If you like the way I explain calculus, chain rule, give this video a thumbs up, subscribe to my channel for more contents like that, and I will meet you all in the next video. Signing out.